All right, so the second half of this video collection, the chemical formula, is going to let us focus on figuring out the identity of a substance, in this case based upon combustion analysis. So we need to go back one more slide. Now, even though this is about combustion, you could apply this to other types of reactions as long as you're given the right kind of information. But since combustion always deals with taking something organic, reacting it with oxygen, producing CO2 and water, assuming it's a complete combustion, you can kind of get a pattern for figuring these things out. So here we go. In a typical question like this, and again, it's appeared sometimes on the AP exam, so it's a good idea for you guys to understand how this works. They're going to give you a mass of CO2 produced by some organic substance. They're going to give you a mass of water produced by some organic substance. And they're going to want you to figure out what is the empirical or the molecular formula of that material. And so this is how you're going to work with it. You're going to use the mass of CO2 to figure out the amount of carbon, because the organic compound, all of the carbon from the organic compound goes into CO2. Likewise, all of the hydrogen from the organic compound goes into the water product. The iffy thing is the oxygen, because the oxygen from the organic compound, if there is any, reacts with more oxygen and goes into both CO2 and water. So there's a little bit of a different method that you have to do to figure out the amount of oxygen. And that's basically, once you know how much carbon and hydrogen, you figure out the mass difference in order to figure out oxygen. So let's take a look at an example. I think it'll be easier than looking at a bunch of instructions. All right, so here's our example. You've got methanol. That's the substance that makes mentholated cough drops smell, gives them that kind of minty, very cool feeling. So it's composed of carbon, hydrogen, and oxygen. So let's say that a sample of the menthol is combusted and it produces that many grams of oxygen or of CO2 that you see, and that many grams of water that you see, 0.2829 and 0.1159. So we want to know what's the empirical formula for methanol, because we're not looking it up, we're not cheating. We're using this as an example to help us practice. If the molar mass of menthol is 156 grams per mole, what is the molecular formula? So we can, if we know that, we can figure out the molecular formula from the empirical formula. All right, so first thing we're going to do, we're going to use the amount of carbon dioxide to figure out the amount of carbon that was in the system. So these are mole problems. So you've got 0.2829 grams of carbon dioxide. Going to convert that into moles of CO2. Then we're going to convert it into moles of carbon, because remember, it's the carbon that we're really worried about. And once we know moles of carbon, we can get it to grams of carbon. And so now we know this many grams of CO2 was created with 0.07715 grams of carbon. All of this carbon came from the menthol. So now we know how many grams of carbon is in the menthol. Same exact idea to figure out hydrogen, but now we're using water. So how many grams of water did we have? Convert that to moles, convert that to moles of hydrogen, and then convert that to grams of hydrogen. So again, all of the hydrogen in the water came from the menthol. So now we know how much carbon, how much hydrogen was in that starting mass of menthol. So if you look back at the question, we had a given amount of menthol. Of that quantity, we know that 0.07715 grams of it is CO2, and we know that 0.01128 grams of it was hydrogen. So if we subtract those two numbers from the mass of the menthol, we then can find how much oxygen is in the menthol. So now we have so many grams of all three materials. Now we're just going to do the same kind of calculation to figure out the empirical formula that you learned how to do in the previous slide. So this many grams of carbon converted into moles, there's my number. This many grams of hydrogen converted to moles, there's my number. Now you might be thinking, well, why didn't I just stop at moles in the previous slide? The problem is we needed to know how many grams of oxygen. The only way to figure out grams of oxygen was to use grams of carbon and hydrogen. So even though it feels like we did too much work in the previous page, we actually needed to do that in order to figure out grams of oxygen. So these numbers we could have gotten previously, but we never would have gotten the moles of oxygen previously if we had not gone to grams of carbon and hydrogen. So I've got this many this many moles of each of the elements. I'm going to divide by my smallest number, which turns out being the oxygen. So I get 9.82, 9.6, and 1.0. This is close enough, even though I would not be comfortable making it a whole, rounding this up to 20. It is actually what you wind up doing. The 9.8 goes to 10, the 19.6 goes to 20. It stays 1 mole of oxygen, so our empirical formula is C10H20O. And as it turns out, that mass is 156. So not only is C10H20 the empirical formula, it is also the molecular formula. All right, so looking back, the only thing that was new is how you actually figure out the grams of each element. And you're going to use CO2 to find carbon, and you're going to use water to find hydrogen, and to find oxygen, then you're going to subtract the other two masses from the substance total. All right, so you've got a couple of problems to do from the textbook that gives you a chance to practice these. So take advantage of this example and go ahead and do that. All right, we are now done with this PowerPoint slide on chemical formulas.